here's another problem. It's going to be a system of equations example. You have 3 hot dogs and a Pepsi, which cost $3.40, and 2 hot dogs and 5 Pepsis cost $7.25. Find the price of a hot dog and the price of a Pepsi by, here's your 3 steps, okay? 1, defining the variables. 2, writing a system of equations. And 3, solving the systems. Normally there's going to be a 4th step here that's going to be write the solution to the question or answer the question. When we have a question like this is what I call a value quantity question, or number quantity, number value, because we have a number of items and we have a cost, and we're trying to figure out the cost per item. Now that sounds like a rate of change. It is a rate of change, but in this question, it's not a y equals mx plus b kind of format. It's price times quantity for each of the 2 different items. So when I want to define the variables, one of the best ways of doing this is to say to yourself, what don't I know? Or if I had to guess this question, what would I be guessing? Number of, okay? Number of what? Number of Cokes, number of Pepsis, okay? Or price of the Cokes, price of the Pepsis, I don't know. We know the numbers, so we're not going to have to guess that. It's the price. So that's where we're going to define our variables. It's going to be, let's choose values at work. H equals the price of a hot dog. And P is going to be the price of a Coke. Pepsi. That's our 2 variables defined, and again, you want to put the units on there, dollar amounts for both of those. If you worked in pennies, it could still work, but you want to make sure you stick with the same units. Now, the system of equations is usually a translation of the 2 phrases. 3 hot dogs and a Pepsi. 3 hot dogs plus a Pepsi adds to $3.40. That's your first equation of the system. The second one, 2 hot dogs and 5 Pepsis. So 2 hot dogs and 5 Pepsis costs $7.25. You might start thinking at this point, hey, I wonder what's more expensive, the hot dogs or the Pepsi? Well, that one, you're going to be able to figure that out. Now we have a system of 2 equations with 2 unknowns. The unknowns are H and P. Those are your 2 equations. You're going to have to solve this as a system of equations. Now, if you saw the video on elimination method, you could do it that way. Otherwise, we're going to isolate a variable in both of them. I would isolate the P because, well, first of all, it's almost isolated already here. I just have to bring the 3H over. And here, I'm just going to divide by 5 after I bring the 2H to the other side. This, again, is going to be your... No, actually, I'll bring that over here and solve the system. P equals 3H, wrong, negative 3H, plus 340. I'll just go 3.4. And in the second equation, after I isolate the P, is going to be P equals negative 2/5 H, and going to divide the 5 on the other side also. For 725 is going to be, darn, can't do this one in my head, 1.9. Let me just double check. 5 into 22, no, 1.45. Okay, $1.45. Doesn't matter about that, alright? And this is the system you're going to solve. Now I got decimals and I got fractions. Well, thankfully enough, the 2/5 works nicely into a 0.4. It'll be a negative 0.4, and you can solve the system by comparison method. You'll finish that on your own.